Okay, you've probably had this exact moment, right? You upload a super complex photo to ChatGPT and it just perfectly describes it. Or you type a quick prompt into Midjourney and boom, it paints an absolute masterpiece. The speed this tech has evolved over just the last year is, frankly, staggering. It literally feels like magic. But here is the big question. How exactly does a computer program actually manage to see, hear, and read at the exact same time? Well, welcome to this explainer on multimodal AI. Over the next few minutes, we're going to give you a super clear, structured breakdown of how this latest generation of AI models actually works. We are going to strip away all the hype, look directly under the hood at the mechanics, and figure out exactly how this tech is reshaping our world. Here's our roadmap for today. First, what is multimodal AI? Then, multimodality in the real world. Next, under the hood, how it works. After that, we'll meet the major AI models, and finally, look at the big training challenges. All right, part one, what exactly is multimodal AI? So think about old AI. It was completely single modal. It lived in a silo, right? A text model could only read and write text, while a vision model could only stare at pixels. But this new AI is multimodal. It's kind of like how you or I watch a movie. We don't just sit there reading a script. We watch the visuals, we listen to the dialogue, the music, and we effortlessly combine sight and sound to understand the whole story. Multimodal AI does exactly that. It connects the dots between entirely different types of data simultaneously. So if we want to get formal about it, multimodal AI is an AI system that can understand and combine multiple modes of information, like text, images, sound, and video, to process real-world problems. And honestly, that real-world part is absolutely crucial. Real-world problems are almost never just a block of text or a standalone image. The world is messy, it's blended, and now, finally, our AI is too. Which brings us to part two, multimodality in the real world. Look, this isn't just some sci-fi concept sitting in a research lab. It is literally everywhere today. Think about ChatGPT with Vision. You can upload a crazy financial chart and just ask it to summarize the trends. Or Google Lens. You can point your phone camera at a menu in a completely different language and instantly see translated text overlaying the real world. Self-driving cars like Teslas rely on this completely. They have to see the road through their cameras, read the text on traffic signals, and process GPS maps all at once. And in healthcare, doctors are now using AI that can analyze your X-ray while simultaneously reading your past patient history to help diagnose diseases. This tech is actively driving cars and saving lives right now. Okay, part three, under the hood, how it actually works. So, how do they actually pull this off? The blueprint for multimodal intelligence basically happens in 5 distinct steps. First, the AI gathers the different inputs. Second, those inputs pass through what we call modality encoders. Third, they enter a shared embedding space. Fourth, a process called fusion and cross-attention kicks in. And finally, step 5, the AI generates an output. Let's peel this onion a bit and really grasp these mechanics. Step 2 is where the real heavy lifting kicks off. Modality encoders act like, well, universal translators. The text encoder processes human words, the image encoder processes pixels, and the audio encoder processes sound waves. Their entire job is to take these wildly different modes of messy human data and translate them into a clean, common mathematical language called vectors. Once everything is translated into math, it all gets dumped into this vast shared embedding space. And this is fascinating. In this mathematical space, similar meanings are mapped physically close together. What does that mean? It means a picture of a car, the audio of a revving engine, and the actual written word car finally become the exact same thing to the AI. They literally all land in the exact same mathematical neighborhood. Next up is the fusion layer. This uses something called multimodal transformers and a really cool concept called cross-attention. Think of this as the AI's reasoning phase. Cross-attention lets the AI link relationships across those different data types. So if you ask the AI to find a red car in a photo, cross-attention is the specific thing linking your written word red directly to the red pixels in the image. It's connecting all the dots before it finally spits out its smart generated response. Moving on to part 4, meet the major AI models. Now, different tech giants are actually solving this puzzle in totally different ways. Take a model like Blip2. It uses a clever bridge approach, taking a vision model and using a small bridge to connect it to an already existing frozen language model. It's kind of like bolting a camera onto a brain. But on the flip side, you have models like Google's Gemini or OpenAI's GPT-4o. They take a completely different path. They are built natively multimodal from the ground up. There's no bridge. They were trained from scratch to process text, images, and audio all inside one single unified model. And that is exactly what makes them so incredibly fast for real-time, complex, interactive stuff. Finally, part 5, the big training challenges. Building these things is not easy. The training requirements are absolutely massive. First off, you have to nail dataset alignment, meaning you need billions of perfectly paired images and captions. Then you use techniques like contrastive learning. This is basically where you train the AI by showing it a picture of a dog with the word dog and pulling those concepts together, while showing it a picture of a cat with the word dog and aggressively pushing them apart. It's how the model learns what things aren't. You also force it to play guessing games, hiding parts of an image and making it predict the missing pieces, which is known as masked modeling. And doing all of this, it requires an unfathomable amount of computing power, tying up massive clusters of GPUs for weeks or even months. And honestly, the roadblocks don't stop at computing power. Data mismatch is a huge, fascinating hurdle. Think about it. Text is sequential, one word after another. Images are spatial, pixels mapped out in a grid. Audio is temporal, sound waves over time. Trying to align spatial pixels with temporal sound waves is conceptually just mind-bendingly difficult. Plus, while we do have billions of data pairs out there, they are full of noise. Because the model relies on human-generated data scraped from the internet, it inadvertently absorbs the cultural and social stereotypes embedded in that text. So pure, objective alignment is incredibly hard. Add in the crazy compute cost, and the fact that we don't even have a perfect single benchmark to evaluate if the AI's reasoning is actually correct. Yeah, you can really see why this is the absolute bleeding edge of computer science. So multimodal AI is basically bridging the gap between isolated data streams. It's allowing computers to process the world in the exact same messy, blended way that you and I do. It sees the road, it reads the sign, it hears the horn. So the ultimate question I want to leave you with is this. As these models completely master our human senses, will multimodal AI be the key that makes artificial intelligence truly, finally human-like? Thanks for checking out this explainer and keep exploring.